Okay, guys, so thank you for staying with us. In this case, we're going to check the well pressure visualizations workflow. Let's remember that Alana has in its database the ability to upload pressure surveys data. If your well requires it, so you can upload, you can use this AlanaPy script to fetch that information, to fetch the pressure information and make workflows using Python, using its tools, using its visualization capabilities to get insight from that data, to elaborate reports, elaborate dashboards, and so on and so forth. Okay, so I've previously created this notebook that has exactly the same elements that we've known already: the import libraries, the authentication process. In this case, I'm only going to use the data source class of the AlanaPy script. I provided the token. I've created the correspondent connections for the server. In this case, I'm using the open server of Alana, and I get the connection established successfully. I'm going to create a list of wells. I think this is the next update for Alana. I'm going to create a function for the script that will create it's going to change the WLF case for the well names, because this is a very repetitive process. But as you can see, the AlanaPy server, it's prone to update it. It's prone to update, and we're going to keep updating it for you guys to work in a more neat way. What I've done this in the 7th execution of the kernel, I'm creating a data frame from the get well pressure function of the instance data source. Let's review just in simple what this function does. If we call it stock string, we have the description, the function that fetches the well pressure data of a given well name. So I need to pass a well name. Okay, so I'm going to call, for example, the first element of this list. We don't have data. We don't have well pressure data of this well. Let's change for the second index, and there you go. We have date, we have the pressure, temperature, if we have an oil rate, maybe the API, a formation, a pressure type, a gauge depth. We have as well some activities of why that pressure survey was taken. We have a sonation parameter here as well. We have a top and a base for the formation, maybe. We have the well FK, in this case for the well name. Okay, we're going to change this, but as you can see, guys, this list of DS in the previous session, in the previous workflow, I called it list of concats. But for the sake of the exercise, we're going to leave it like that. But we are going to create, in this case, a concat data frame using that list of data frames. There you go. And we know already that that data frame has all of the wells in it. And we need to change that well ID, the well ID column. Okay, so I'm going to do exactly the same from the database, from the server. I'm going to call the get well master, the well name and its ID. I'm going to create a dictionary of those two elements, and then I'm going to use the replace function of pandas to replace those well FKs, and I'm going to put that replacement in a column called well name. Okay, So as you can see, if I call the head function, there you go. We have the appropriate well name for each well FK, okay? I'm going to create a function for later sessions that will avoid, it will try to avoid this, this method, and it's going to be a much more easier way to change it, okay? Excellent. So I don't know if you guys remember the pyplot variable that we created in the previous session. I'm just going to then again pass on a dict config, and the pyplot variable, in this case the pyplot, the function, okay? In this case, we see that if we call, instead of the intervention type, maybe the activities, let's PBTs, and we are going to call exactly this here below everything. If we run it, there you go. We have the pyplot of activities. We have a 55% of very low oil carrier transmission. We have very low transmissibility interval, gas and oil. We have good water carrier transmissibility. We have several measurements of salts. We have closed intervals. We have a failure due to leakage through the column. And we have a count of activities. As you can see, as you guys can see here, we can't visualize it that quite good. So what happens if instead of having like this, we create a simple loop, but instead of looping, I'm going to loop in these two columns, in these three columns: pressure type, activities, and well names. Okay, and let's create this list, and we're going to for call in the list of calls. There you go. I'm going to use this dict config. I'm going to update it every time it's looping. There we go, the appropriate instance, and in this case, I'm passing on the call, the looping element, and I'm going to call pyplot variables, and I'm going to pass on the dict config. We run it, there you go. We have only one pressure type, and then pressure type. We have several counts of this pressure type classification. The element activities, the several activities of this database or data frame, and this is interesting. We have 45% of the well pressure data data. It's regarding the F14 well. 18% goes for the F5, 18 as well, and in fact we have three wells that has the same occurrences of well pressure data gather, and we have the counts for this. We have 5 for the F14, and we have 2 for the rest of them. Okay, excellent. So let's make a little bit a much more detailed. Let's see the df concat columns. We have, for example, we have in this case the gauge depth. We have the formation, the pressure of each datum. We have the temperature, we have the activities. Let's see the DF. I want to see the unique values. In fact, we're going to create a simple loop. For well, I'm going to df concat. I'm going to call the well dot unique. It's going to give me a list, and I'm looping on that list. I'm going to create a df temp using the df concat, but the df concat well name is going to be equals well, and I want to print f activities in well column well. I'm going to skip a line, and I'm going to print the df temp activities column dot unique. Let's see what we get from this. Something happened here. Yes, of course. What is wrong with this? df temp. I don't see anything unmatched. Yes, of course. I need to avoid this punctuation mark. There we go. df is not defined. df what? df concat, of course. If concat goes here and here for the Boolean. There you go. For example, here, I'm going to skip a line at the end for a much more good visualization. Activities in well F11, we have only failure due to leakage and closed interval. For the F14, we have very low oil carrier transmission. And activities for the F4, we have good water transmissibility. We have very low oil carrier transmission. And the activities in that pressure datum, for the F5, we have very low transmissibility interval gas and oil. Excellent. We can keep going and digging further with maybe running the well intervention, this statistics tools that we've seen, his plot, count plots, maybe using some grouping in order to visualize much more further regarding the columns of the classification or the activities of each pressure gather. But in this case, I'm going to use the Plotly graph object function of that has Plotly, and I'm going to paste function here, which is going to create then again. Now, I don't know if I previously declared the list of wells, but I think I did. Yes, there you go. I'm looping in wells, and I'm creating a temporary data frame, and I'm creating a gauge and number indicator. If we go to the documentation of Plotly, we have several visualizations there. One which is the gauge plus number, and we're going to pass on several information. In this case, the value, it's going to be the mean, the average of the pressure column. okay? And as a title, I'm going to put the average pressure for maybe for this one. And I'm going to create several kind of visualization aids, some ranges to have a much more neater way to visualize the gauge form. Okay, if I run it, as you guys was able to see in previous, we don't have all the wells. We don't have information regarding the pressure coverage of all the wells. In this case, we don't have data from the F1. We have the average pressure for the F11. Maybe the ranges of pressure of this well were between 215 and 400. And that's why I kind of place this marker here, right? And the maximum value for the pressure, maybe it's in this red marker. But the average, it's 438. We don't have any data for the F12. The F14 ranges then again. The F15 doesn't have data. The F14, the F4, sorry, goes almost like 500. The F5 goes beyond 500. So I think that you guys can see all that we can leverage all the tools, visualization tools, to create kind of conclusion or gather conclusion of our data, of the data that we upload and that we give Alana, and that we kind of fetch using the AlanaPy script. Okay, so I think that that would be all for this topic. Let's move on to the questions and answers. So